Welcome. I'm Sam Fleming, Chief Technology Officer of Moat Metrics. Moat Metrics provides the competitive intelligence interface here, what we call the Moat Competitive Intelligence Solution. It's a plugin for the GPT type agents. So like here we're using Claude today. We use it for diving in and getting a little bit more detail. When we talk about competitive intelligence, what we're really looking for is how do we understand what competitively differentiates a company. I think a lot of times people are from a variety of use cases, whether it's insurance underwriting or investment type due diligence. There's a lot of sort of, a lack of transparency around what actually competitively differentiates a company. You can often see, sort of the claims that are made out there in presentations or on websites. But does that actually sort of hold up to a deeper level of rigor? And that's what we're going to apply here in this exercise. So I'm going to show my workflow here today. I'm going to do a few jump cuts here just when Claude is thinking as it's responding to these things, just in the interest of time and speed, but basically show you my workflow and how I'm going to delve into Tempus AI. So here we go. I started with this first prompt just to look up the mix codes. Again, our mix codes are the Moat Industrial Classification System, so basically taking classification systems to the next level of depth and granularity. We want higher fidelity than what is typically available through classic systems like a NAICS or a GICS or BICS, etc. So with that in mind, that allows us to get down to specific technology areas to sort of align and map and understand. In this case, we use a lot of patent detail to understand what a company is doing from a behavioral level. Provides pretty good fidelity as far as what a company is involved in. But there is broad-based just sort of understanding that they're part of a classification, and that allows us to sort of provide context to Claude. And that's really what this exercise is starting out with, is building up that context. So we'll start here with looking up the mix codes for Tempus AI. I ran that first query just to get that basic information. So we can see that we've found that in the system, it runs out to the Moat system here, the MCI plugin. They have 116 patents, so that looks like the right entity. And then it breaks down where they're focused. So core healthcare, IT and data, bioinformatics, electronic medical records, genomics and diagnostics, getting into some RNA sequencing, precision medicine, medical imaging, AI, ML, and clinical tools. And then gives us a little summary around the portfolio. So what I want to do, I think, here is I'm kind of interested in understanding the genomics and diagnostics and that pairing of AI and sort of what sort of competitively differentiates them in those classes. So let's look at that. Okay, so here we've gone in and with this question, let's dig deeper into the genomics and diagnostics areas. So it's gone through, run those, and developed a little bit of a competitive landscape here. Market positioning, considers it a mid-tier player, small patent portfolio, relatively speaking. Next-gen sequencing, precision medicine, it's ranked number 1, only 16 patents active in this mix. So it's a very specific area. That's interesting. Tempus is not competing on sequencing platforms, but clinical decision support systems and AI ML applied to genomics. All right. Patent portfolio analysis, some of the problems they've solved. I won't dig into the specifics of that. Litigation risk. Not really much going on there. There are lawsuits that happen there, but a lot of MPE, non-practicing entities, trolls there. So Guardant Health likes to defend its position, 19 cases. Always interesting in healthcare how aggressive companies can be. Tempus's low litigation suggests they're not threatening incumbents' core IP yet. All right. Yeah, typically when you start growing and producing revenues, that's where you get into trouble. So portfolio strengths, low litigation risk, strategic recommendations, double down on the AI layer. Okay, so we've run this question now. Let's dig deeper on precision medicine and in particular how they are leveraging AI. Drop down the results here. So strategic position, the data integration layer. Integrate multimodal data, predict clinical outcomes, automate clinical decision support, which tests to run, which therapies use, which trials to enroll in. A little bit here on the competitive landscape. The AI-powered precision medicine patent portfolio. So they've got some of their key patents here. ML models to predict whether a cancer will metastasize, which organ will spread to, and when. Sounds pretty powerful. Adaptive model selection, site-specific prediction, feature extraction, and sparse data. So it says this is a breakthrough innovation here, oncogenic signaling pathway prediction. So they're actually processing images to determine the oncogenic signals. Instead of sequencing DNA and RNA, they predict the gene expression pathway activation directly from the H&E histology slides or radiology images. So basically image-based AI recognition of these issues. Problem solved, so you don't have to go to the genetic testing, you can just run the images through the AI. That's pretty cool. It's faster turnaround. Rare variants can be hard to detect with gene by gene analysis. So you're actually looking at sort of pictures to determine whether it exists or not. It's pretty interesting. Let's see here. Actually, ability to predict drug-resistant mechanisms. That's interesting. Identify rare tumor subtypes. Complement or replace gene expression assays. This is huge if Tempus can predict genomic pathways from cheaper, faster imaging. They bypass the need for expensive NGS in some cases. That's pretty cool. So this patent here predicts who will respond to immunotherapy. Detect when tumors evade immune surveillance. They're doing some pretty interesting stuff from a patenting perspective. It sounds like they're solving some significant challenges. Donor-recipient matching. Patient embedding, donor embedding, similarity matching, outcome prediction. That's pretty cool. Demonstrates the ability to generalize beyond oncology. Enters a organ transplantation market. I don't know if that opportunity is sort of recognized in their price as a stock today, but it sounds like that's a big one if you can get into matching organ donor transplant. So the Tempus data moat, this is interesting. So Tempus's real competitive advantage isn't its individual patents, it's the proprietary data set they've built. 6 million patients, longitudinal outcomes, to actually know what happens on these outcomes. So that means they've got end-to-end patient tracking, multimodal integration, the flywheel, more patient data, better ML models. Better models, more physician adoption. So it seems like they're interacting down to the physician layer, which is pretty interesting. Patents protect the data processing methods in ML architectures. Okay, so we've run now our fourth question here. How have they managed to develop this comprehensive data set? It seems to be a sort of network effect. Please characterize this advantage over its peers. So it actually is diving outside of the Moat data here, going out to outside web sources, doing web searches. The Tempus data flywheel, four-sided network effect. So it agrees with my assertion that that creates sort of a network effect here. It's not just a testing lab or software platform, they're vertically integrated that creates compounding advantages. So here's their sort of current scale, 40 million clinical patient records, 9 million de-identified. So that's a way they can share that data or sell that data in a way that doesn't actually release any personally identifiable information or healthcare data. 2,000 plus healthcare institutions with active data connections. That's really interesting to me, right? Like that's their network, which is probably growing, and they're collecting all that data and gathering all the tests and samples from that. So the integrated laboratory model, the Genius business model, free tests and data monetization. That's kind of interesting. So they do the laboratory work, and then they do subsidized free testing. So most patients pay less than $100 for sequencing tests versus the market price of $3,000 to $5,000. Well, that's pretty compelling. I can see that growing your volume. Insurance reimbursement covers the cost. Low patient cost, high physician adoption is more data volume. So they've sort of got that sort of recursive loop going on. Multimodal data capture. So genomics, pathology, radiology, EHR, seems that that's an advantage, that they just have this sort of multiple dimensions or vectors that they're collecting this across. Triple monetization of the same data. So the first revenue is the reinsurance for the test, the reimbursement. Second is licensing the data out. So they got 18 of the top 20 pharma companies, and that 25 to 50 per patient record. That's probably the licensing rate, I'm guessing. That's kind of crazy. And then their third revenue, clinical trial matching. So they can actually do trials work. So pharma companies need to pay them to run the trials and see what happens from an outcome perspective. Proprietary AI models built on proprietary data. That's a big one, right? So they are building AI models, but the others, their peers, don't have that data set to go after and actually, create their own models. Recent $200 million partnership with AstraZeneca. So companies, pharmaceuticals are coming to them in order to get access to that data set, because there just isn't, I guess, another source. I mean, certainly these pharmacies or pharmaceuticals don't have their own data collection network. So here's the four-sided network effect, characterizing that. So current network of 7,000 physicians and 65% of academic medical centers. So they have more than 50% of USA oncologists already in here. That's pretty crazy. So free low-cost testing, fast turnaround. It was previously mentioned that it takes weeks using other systems, so they get these in 7 to 9 days. AI decision support. Clinical trial matching for patients, identify what is the best opportunities for their patients. This is interesting, their network effect characterization here. So more physicians ordering tests, more data, better AI recommendations, and then more physicians want access. Sort of interesting cycle they've created there. A virtuous cycle. So side two, so we've covered side one, the physicians, the supply side. We're going through their four-sided network effect here. So the physician side, the patients, the demand side, so comprehensive genomic profiling at little to no cost, access to clinical trials, personalized treatment recommendations. And then the pharma biotech is the third one. They want access to that data, so they're willing to pay for that. There seems to be some validation for that. If you got 18 of the top 20 pharmaceuticals that want access to it, it must be a good data set. Then side four, healthcare systems, data providers. So they got 4,500 data integrations across 2,000 plus healthcare institutions, AI tools for care gap analysis, quality improvement insights, and they actually do revenue sharing back on that data licensing in some partnerships. That's interesting. I wonder if that's the case with newer partnerships, or if that was just something they originally used to get the flywheel going. So this is also interesting that Claude is saying this is a nearly impossible to replicate moat. Sounds compelling. So time to build advantage, 10-year head start. So they started in 2015. They've accumulated data for those 10 years. compound effects, early data enables better AI. Better AI attracts more physicians. Competitor problem started today. You need 10 years to build comparable longitudinal outcome data. No competitor has all 4 modalities at scale. So the modalities being genomics, pathology, radiology, EHR integration. And that is interesting, right? That last one, they've got the 4,500 integrations. They're pulling that into as their data source on those healthcare systems. So Flatiron, Roche has some capability there. Obviously has an EHR system that they're collecting that through that acquisition of Flatiron, but it seems to be missing on these others. But again, having that data seems to be a key aspect here. That is probably one of the companies that Roche could come back and start leveraging that. But again, strong head start on the AI front for Tempus here, even with that data in hand. Why this matters: Tempus patents show their metastasis prediction, oncogenic pathway detection, all require multimodal data integration. Competitors with single modalities can't build comparable AI models. We'll kind of believe that. Not quite qualified to differentiate whether that metastasis and the sort of, I could assume that having all those different dimensions is helpful. The cold start problem for competitors: building the labs, get insurance contracts, recruit physicians, integrate with hospitals, accumulate longitudinal data, train competitive AI models from millions of samples. It's really estimating that it's a 10-year, $500 million plus investment. So possible for some of the big boys, I'm sure, but it's, again, your time to market to catch up, and this company's off and running, already has the data, already evolving its models. Pretty compelling in my mind. The data network effects creative winner takes most dynamics, so adding patients, every additional incremental patient makes all previous AI models better. For a competitor with 100,000 samples, can't train comparable models, can't offerable comparable insights. So why peers can't catch up? Foundation Medicine, which is a Roche company. I'm not going to dig into each of these individually here. We'll just slide past these. So the patents form a moat reinforcement. So you can see how the patent IP protects the data advantage. So the data integration patents are the hardest in its estimate here. Again, this is the AI estimating. That these could be hard to work around. The metastasis predictions, if nobody else has those multiple sources, they're not even started on the metastasis prediction. The oncogenic pathways requires imaging and genomics and outcomes data. And it really seems like the sort of intersection of these things has created a really strong moat around what they're doing here. So the patents don't just protect the algorithms, they protect the data pipeline that feeds the algorithms. Competitors can't train comparable models without comparable multimodal data sets. The network effect amplification, clinical trial matching patents, makes physician networks stickier. Donor matching. So the patents create a thicket around the data flywheel, making it legally risky to replicate even if technically feasible. So quantifying the advantage, data depth comparison. So Tempus has 9 million de-identified patient records with 4 million sequence samples. Multimodal records, 1.5 million with genomics and clinical, 2 million with imaging data, and 300,000 plus with genomics and transcriptomics. Foundation Medicine, let's see. These are comparing some of the competitors here. Foundation Medicine Limited, imaging, EHR integration, Garden, blood-based testing only. Can't get to that multinomic, obviously, and pretty limited multimodal data. Flatiron has clinical data, no molecular genomic testing, and must integrate external results. So the Tempus Foundation model, training on 40 million records, they've kind of got that validation that AstraZeneca was willing to pay for it at a high price, $25 a record, and it's operationalized. So the strategic insight, why this is defensible: network effect compound over time, physicians are adding to the data, patient makes predictions better for all future patients, each pharma partnership funds more AI development. It's interesting, they're talking about that gap widens with each additional quarter. They're accelerating that. Multimodal requirement creates a natural monopoly. So to compete, you need to win all 4 capabilities: labs, pathology, radiology, and EHR. Data licensing creates recurring revenue. That's kind of interesting. It's quoting building all 4 in that prior one. I just saw that. They're saying it's basically nearly impossible to build all 4 simultaneously in terms of labs, pathology, radiology, and EHR. So that multimodal is obviously a winning formula there. Get licensing revenue on the data. That's a recurring, and it's a high margin business. Very cool. Regulatory moat. Does say there's some vulnerabilities, just the deep tech or deep pockets with big tech. The ability to partner with existing labs to replicate models. Question that a little bit. I mean, that's a tough one. If there is an existing best, you're not going to go to the second best in this case. I think the earlier point of one winner takes most really pertains here. As a patient, I don't want my stuff being run through the second best model. So difficult, I think, for some of these others, even with deep pockets, to recreate that. So bottom line, the moat is real and growing. So the integrated labs, physician network, multimodal data, longitudinal outcomes, scale advantages, triple monetization of testing revenue, data licensing, and AI products, patent protection, and the network effects. The patents we analyzed earlier protect the methods for integrating multimodal data, training AI on longitudinal outcomes, automating clinical decision support, and matching patients to trials and therapies. But the real data moat is the data itself. 10 years of multimodal, longitudinal patient outcomes cannot be replicated quickly or cheaply. Strategic conclusion: Tempus has achieved escape velocity. The data flywheel is spinning fast enough that competitors can't catch up without massive multi-year investments, and the patents provide the legal protection around this. So this is actually pretty compelling. I mean, from an objective perspective here, we set out to do, and again, this was our 4th question in. So trying to understand how a company differentiates itself, whether it actually has competitive differentiators, how it's postured in the marketplace, and whether that's sort of a stronghold, as well as understand what they do. I feel like having gone through this, I have a much better understanding of Tempus AI, which is always the challenge, right? Do you really understand what a company is doing? And I think that we've demonstrated again here that with Claude, in terms of a foundational model and tying it into real world data, that it gives you consistency and is aligned and grounded in sort of a layer of truth, understanding the underlying patent behaviors, the underlying litigation risks. This really sort of puts a well-crafted formulation in terms of understanding how this company stacks up amongst its peers and what its future prospects are. This is one of the more compelling ones that I've done, honestly. It's pretty interesting in terms of how this company's positioned itself from a data gathering perspective and integrating into the EHR systems, as well as how they protected it from a patenting perspective and built the AI models around it over the last 10 years. So very impressive. And I hope you enjoyed this presentation. If you have ideas on other companies you'd like to see run, other questions that you'd like to see sort of incorporated in this workflow, please leave a note in the comments and subscribe to see future companies that we run through this process. Thank you.